the name of any objects that are included in my depends on statement and hit evaluate, I now get errors. Unknown property transform and undefined, because no longer does $.21 exist. It's now $.21_AA. I'll remove that for now. So it's working again. So I can't change the name of any objects. The other problem is the clavicle to upper arm bone has a lot of degrees of rotation to it. As I discussed before, it can't rotate above being in line with the clavicle. So you can't actually rotate this joint up like this. So we don't need to worry about it going up. We do, however, need to worry about it going down a long ways. This bone can actually be pulled down a long ways. And you can actually notice that as I do this, see if I can get it to happen really badly. This bone will start to twist against these ones. It's kind of hard to see, but you'll actually start to see it twisting out of control. And that's probably happening there, where it's no longer trying to stay aligned. It's actually flipping over on us. We can actually minimize how some of that flip happens by rotating the object that it's calculating the rotations between. If it's flipping when it hits 90 degrees of this one here, and we know it doesn't need to go up past it, past 90 degrees, means we can actually rotate it and cheat it down a bit and say, well, we know we're not going to get up past this angle here anyways. We just simply shouldn't be doing it, or else we're ripping the shoulder joint apart. It's doing something very unnatural. Now it gives us a huge latitude. We can rotate this bone all the way around to here before we ever hit 90 degrees, which would mean the arm would just be passing right back through itself. So there's a good little cheat to stop it from flipping. On the axis forward and backwards, we won't get a flip because it's around the z-axis, and the z-axis flips at 180. It was only the y that was going to flip it at 90. Just like we had the same problem down here with the look-ats. So there's a great little cheat to get around that. The next cheat requires a little bit more scripting again. This next cheat is to get around having name-dependent script controllers. Call it a cheat or whatever you want. This is the way it works very nicely. We're going to use a bit of max script again, and we're going to create a custom attributes. Oops. The attribute is going to hold the nodes that we're currently using in our depends on statement, and we're referencing. So we're going to create some nodes that are just going to store them. And we're going to store those nodes in this custom attribute and then reference the custom attribute. So if the name of the object changes, it doesn't matter because we're actually looking at the node itself. The name will change. It'll just pass it right into the custom attribute and right back into our script again, and it won't break when the name changes. I'm just going to call it node store. Sorry, attributes, it should say. And then I'm going to give it a param block. Call it node P. And unlike when we create the interfaces for the hands or feet, we don't need any rollout. We don't need any control interface. We just need parameters to store data in. In this case, we're going to call it UP arm for upper arm. And we're going to create another parameter called UP arm P for parent, or we can call it whatever we want, but this is going to refer to the helper. we have